Hey, everybody. This is Mr. G coming at you live from our middle school here at DePaul. And this is a video for 6.1 Algebraic Expressions, our first video that we're doing. So, you guys, what we're going to talk about today is simplifying algebraic expressions and how to do that. So, when we say algebraic, we're just talking about stuff with algebra, with stuff with variables. Okay, so we're looking at expressions like this. So 10h plus 25 plus 14h plus 18. And we're just going to make this look a little less complicated. So what we mean by that is, one, an algebraic expression has multiple parts to it. So we always have our variable, which is the letter. Okay, I know it's that letter that no one likes that they brought into math, but it's the letter. So that's our variable. That's the unknown value. We don't know what this letter represents. It represents a number. We're just not sure what it is yet. Okay, so that's why we use the variable. We also have, if there's a number attached to the variable right in front of it, these two numbers are being multiplied right here. So 10 and h. This is 10 times h whenever it's attached to it. And we call that 10 a coefficient. Okay, so that's always, the coefficient is just a vocabulary term of the number that is attached to your variable and they're being multiplied. Now, a term is all of the coefficient with the variable. So 14h right here would be a term. Positive 25, even though there's no variable, that is still considered a term. Okay, it is a term because it is this one piece that is being added or subtracted with everything else. Okay, so what we're going to do is we want to make this expression look just a little bit easier to look at. Okay, and the reason why it's an expression and not an equation is because there's no equal sign. If this was equals 2, then we'd be able to figure out what h is, and we'd actually be able to solve this equation. It's an equation because it has an equal sign, the equal equation, so on and so forth. But it doesn't have that equal sign, so therefore we cannot figure out what our unknown is or our variable is. And so therefore we're just going to simplify this, make it look a little nice to look at, and that's it. So pretty easy stuff. So let's look down here. So here's the same exact problem up there. And what we're going to do is to simplify, we're going to do what's called combine like terms. Now, with combine like terms, it's really simple. What we're going to do is we're going to look at these terms that look similar to each other. And we have to follow certain rules with combining like terms, and we'll talk about what rules those are. So if I have a variable attached with a coefficient and a variable, if I have a term that has a variable, I can combine it with terms that are with the same exact variable. So for example, I have 10h here. I'm going to put that in a box. I'm going to look to see if I have any other terms that have an h in there. And we have this positive 14h. Notice how I included the sign with it, because the sign always follows the value that follows it. Always goes with it. So I have this 10h, I have this 14h. I can combine those. If I have positive 10 and I have positive 14, that gives me a positive 24. And you just include the variable with it. So that's 24h, and that's it. If I have 10 h's here, 14 h's here, that means I have 24 h's in total. Now, this 25 and this 18, these are also known as constants. These do not have a variable attached, so these are also like terms. Okay, so you can underline some like terms and box like terms. You can put triangles, you can put circles, whatever you want to do to identify what's a like term. So I have this 25, I have this 18, both are positive, so I can just combine positive 25 with positive 18 to get positive 43. So I change this expression into this expression, and I'm all done. Now, these are the exact same expression. These are just written in different ways. This is a simplified version because I only have one of each of the same, one of each like term. I only have one value that has an h in it, and I only have one value that doesn't have a variable in it. And that's it. I cannot simplify this anymore. I don't know what h is because I don't have an equal sign, so I can't figure it out. So we just simplify it to just here. Okay. Another thing that you're going to look at with expressions is you're also going to have to do the distributive property. Okay, this is also possibly a new vocabulary term. So with the distributive property, what we're going to do is it's multiplication, guys. So if we see here, we always know that if a number is attached to a parenthesis with no sign in between, that it is multiplication. So what this is 4 times 3x minus 5. So I'm taking 4 and I am multiplying it by everything inside my parentheses. So I'm taking 4 and I'm multiplying it by 3x. And I can do that down here right below it. So I'm going to take 4 and multiply it by 3x. Now what we're doing, you guys, is we are just getting rid of these parentheses. Okay, so the goal is to get rid of these parentheses to make an expression that looks like this one that we had here. Okay, that's the ultimate goal here. So I'm taking 4, I'm multiplying it by 3x. I am also going to take 4, and I have to multiply it by the second value inside those parentheses. So I just take 4 and multiply it by negative 5. So I'm taking 4, and I'm multiplying it by negative 5. Okay. So 4 times 3x does give me 12x. 4 times negative 5. And the reason why, I'm sorry, let me go back. 4 times 3x, when you multiply, even though it has a variable here with this x, that's okay. You still just multiply the coefficient by the value. So I'm just doing 4 times 3, which is 12. It's like saying I have 3 x's here, and I have those 3 x's 4 times. So I really have 12 x's. Okay, so I did 4 times 3, which gave me 12x. Now I have 4 times negative 5. Positive times a negative is negative 20. So now I got rid of those parentheses to simplify this expression by using the distributive property. And I just have 12x minus 20. And I can't simplify it any further. There's no like terms for me to combine. I can't combine 12x with negative 20 because 12x has this variable here. And with the variable, I can't combine something with a variable with something that does not have a variable. They're not like terms. So there's nothing more I can do here, and I am all done. I cannot do 12 minus 20 here because this is 12 x's. This is just 20 as a number. So I got to stop here, and I'm done. So recap, distributive property, we just multiply the number outside the parentheses by everything inside the parentheses. I'm taking 4, multiplying by 3x, taking 4, multiplying it by negative 5. If I had another number, I'm just going to make a problem real quick. If I had this, I could technically do 4 times 3x, 4 times negative 5, and 4 times 2 if I wanted to. Okay, so that's how we can use it. You can distribute that 4 to every single piece inside the parentheses, even if you have more than 2. Okay, just so you guys know. All right, so here's another example of distributed property. What I want you guys to do is try this on your own first. Just see how you do it without, just pause the video, and then you can play it and then watch me solve it as well, just to make sure you do it right. So pause it real quick, try it on your own, see if you know what you're doing, and then check your answer. So again, this is distributive property because I have negative 2 attached to a parenthesis. There's no sign in between, so we know it's multiplication. So I have negative 2 times 4x minus 7. So I need to multiply this negative 2 by every term inside these parentheses. I'm taking negative 2, multiplying it by 4x, taking negative 2, and I'm also multiplying it by negative 7. So I have negative 2 times 4x, and I also have negative 2 times negative 7. Okay, negative 2 times positive 4x. If I have a negative times a positive, my answer is going to be negative. Negative 2 times 4 is negative 8, and just bring your variable with it. Negative times a negative is positive, so notice how I'm just going to write my sign within my expression. And then 2 times 7 is 14, so I get negative 8x plus 14. I am done. Hopefully you guys got that one. Okay, this one's, sometimes this takes a little bit of practice, but it's not too bad. Oh, I got a quick joke for you guys too. So the joke is, this is a good one too. Why are our math books always so sad? So why is a math book always so sad? Because it has so many problems. All right, moving forward. Okay, factoring expressions. This is our last thing we're going to talk about today. So factoring expressions is the distributive property, but backwards. So this is a skill that we use a lot in algebra. It's good to see what it looks like now because sometimes we need to factor in order to solve really, really easily. So when we factor expressions, we're doing the distributive property backwards. So if you look right here, this is already a simplified expression. So I have 4x plus 8. Okay, so it's already simplified. There's nothing we can do here. But sometimes we'll be asked to factor the expression. So what we're going to do to factor is it's kind of like simplifying a fraction. You're going to figure out what value do these have in common that I can divide them both by. So what's the greatest common factor that they have that I can divide both numbers by evenly? Okay, so if I look at 4 and 8, 4 and 8 can both be divided by 4, right? Because 4 divided by 4 is just 1. 8 divided by 4 is 2. So I can divide both of these by 4. So what I'm going to do is I'm going to do just that. I'm going to divide both of these by 4. I don't know why I erased that. But instead of actually doing the division, I'm pulling the 4 out, and then I'm making it look like what we had before with the distributive property, before we actually distributed. I'm pulling the 4 out, I'm dividing it out, and 4 divided by 4 is 1, right? So I have 1x. 8 divided by 4 is 2. So what I have is I have 4 times 1x plus 2. So by dividing both of these numbers by 4, I can't actually do the division because I don't have an equal sign, so I can't just decide, hey, I want to divide these numbers by 4. What I can do is I can pull the 4 out, put it in parentheses, because division is the opposite of multiplication. So that's why I changed it into a multiplication problem by doing this division here. And I'm writing what my values are left with once I do that division. So by dividing both by 4, 4 divided by 4 is 1. 8 divided by 4 is 2. But then I pulled the 4 out and wrote it as multiplication in front of some parentheses, like it looks like we need to distribute, and I'm done. I just factored this expression. Again, sometimes we need to do this to solve unique equations, so it's a good skill to have, and it just takes a little bit of practice. The way you check your answer here, guys, is you just do distributive property again. I can say, okay, let me check my answer, because I should get the same thing if I distribute. 4 times 1x, cool, that's 4x. 4 times 2, all right, cool, that's positive 8. Look, I got the same thing. I know I factored correctly. I'm good to go. So it's just doing the distributive property backwards. Instead of multiplying, we're dividing by the greatest common factor, and we got to pick that common factor. So here's an example, same thing. Pause it real quick. Try it. See if you can identify the greatest common factor and then divide it out. Okay? And then pause it and then try it and then see how I do it. So greatest common factor here. I'm looking to see what number do these have in common that I can divide them both by evenly. I have 3 is a possible factor. I have 4. And I also have 6. I also had 2. There's a lot of common factors here. But we always want to pick the greatest. And 6 would be our largest common factor here. Because if I divide both of these by 6, it would be an even value. I can't divide by 12 because 18 cannot be divided by 12. So if you thought it was 12, you're right. You could divide 12 by 12, but I can't divide 18 by 12. So I got 12x divided by 6, 18 divided by 6. So now, because I'm choosing to use 6, that's going to come outside my parentheses. 12 divided by 6 is just 2. Keep the variable with it. 18 divided by 6 is 3. So I get 6 times 2x plus 3. I factored out this expression to make it look like this. I can check my work by doing the distributive property if I want, and I know I will get the same answer. Finally, guys, if you'd like to, I would like you guys to try this problem out. This kind of combines a little bit of everything. It doesn't combine factoring, but this is combining like terms and distributive property. So this here looks like it's fairly complicated, but what we can do is we can simplify it to make it look just like something that looks like this, like 12x plus 18. Okay, so give it a shot, and then you can see how I do it, and we'll go from there. Okay, so I have 7 times x right here, and I also have 7 times negative 4. Okay, so 7 times x is just 7x. If I have x once, this isn't like even having a 1x right here. If there's not a number in front of it, there's a 1. Okay, so 7 times 1 is 7. 7 times negative 4 is negative 28. So what I did the distributive property here, and it gave me 7x minus 28. But now I got to continue on over here. I'm going to bring down this plus sign. And now I got to continue on and do the distributive property as well with this set of numbers. So I got to do 2 times negative 3x and 2 times 5. So I'm doing the distributive property twice here. 2 times negative 3x is negative 6x. 2 times 5 is positive 10. So I have 7x minus 28 plus negative 6x plus 10. I really don't need this plus sign here. Whenever you're adding a negative, it's really just the same thing as subtracting. So if I were to erase that, it would actually mean the same thing. So let's just go ahead and do that. There we go. Now I get to combine my like terms. So I'm going to look for which ones have the variable. I have a 7x. I have a negative 6x. Positive 7, negative 6. So when I do 7 minus 6 here, when I combine these two boxes, 7 x's, 6 negative x's, I'm left with just 1x. Okay? Negative 28, positive 10. I'm combining those. I have different signs. Keep the sign of the bigger number. So I know my answer has to be negative. I have a lot more negatives than I do positives. And then I need to, because they're different signs, I'm really just going to subtract these numbers. Okay, and I'm left with 18. So my answer is negative 18. So I have 1x minus 18, which we could also write as just x minus 18. These are both the same thing. When you have a 1 in front, you don't need to write it in front of your variable because 1x is the same thing as just having this 1x right here. And I'm done. Okay, so that's it, guys. Hopefully this helped. And if you have any questions, please let me know. Let me help you guys out. Get some practice in. And this should be pretty easy once we get a lot of practice going, okay? So good luck, and thanks for watching.